Hey, hi, good morning. So welcome to module 2 of the Grokking Artificial Intelligence of Things course. So in this module, we'll be talking a little bit more about the connectivity. How do we actually connect and transfer data from the sensors that we have, or the artificial intelligence sensors, and actually bring them to a place where they can be actually processed. So this is actually the second module. So in the previous module, we talked about how the data is actually collected by the various devices. And we have mentioned that for AIoT, the devices need to be a little bit more sophisticated than the basic IoT devices that we find. And simply mainly because there needs to be more power to actually do some computation and run some algorithms on the devices themselves. So over here, for this portion, we'll be talking about the connectivity, how the data is actually brought over from the devices onto the cloud or from the server or whatever back-end processing that you're doing. In the next module, we'll talk about the AI processing that we'll do. And finally, we'll talk a little bit about the cloud services that can support AIoT. So this is the outline for my module this morning. So we'll start with distributed computing. Why is it necessary for AIoT and IoT? Then we'll talk a little bit more about the various data formats that are very common for IoT and AIoT devices. And then we move on to the networking or communications portion. So talk about the 5G and other wireless mechanisms. And lastly, we'll follow up in the next segment on the IoT protocols, MQTT, etc. And also this very interesting area called the Web of Things. So first of all, why is there a need for distributed processing for AIoT and IoT? A distributed processing means that the computational power is not just concentrated in one place, but it's actually distributed over the network. So first of all, data is actually available everywhere. Images, speech, weather information, telemetry data from your car, your last EMI, stock prices is actually not present only in one particular location, but it's actually coming from various points in the network. And with the integration of the Internet of Things, the amount of data that is going to be generated is going to increase many-fold beyond what we are already encountering in the internet today. So for example, we will have sensor readings, which will be taking room temperatures. We could have agricultural sensors taking in information about the soil, alkalinity, tree sensors, air sensors, about the environmental information. This data has to be collected and then stored and made available in various formats. So simply put, the volume and velocity of data is going to be increasing tremendously in the age of the Internet of Things. So this big data processing capability needs a distributed processing resource, because just imagine if you actually concentrate all this information in just one spot, that cloud service that you have, no matter how large it is, going to be very quickly overwhelmed just by the very fact that there's just too much information flowing in at the same time. So we need to have a way to spread out the load so that we can share the load across many different servers. Right, so the other thing which is maybe not so obvious to the less technically inclined is actually, if you look at the diagram that I have on the top right-hand corner, you will actually see that actually for engineers, they know that for a long time that when we have a control system in place and we try to, let's say, stop a lift or stop a train at a particular position, if there's a delay in the sensor information reaching the controller, and then the controller the controller that you have trying to send back some command to actually apply the brakes, the delay between the sensor information on the one hand and the actual control output that you exert in your actuator you can see for the first amplitude response, right? If there's a very tiny delay, small delay, the response will be very smooth, right? It's very smooth, right? If there's some amount of delay, but it's still a reasonable, not huge amount of delay, you will start seeing some of this control or oscillations that you will encounter. And when there's a very large delay, actually the system becomes unstable. You can no longer control the system. In our own real life experience, we often find that this to be the case. Let's say you are trying to actually balance something and you are not able to react fast enough, you will find it very difficult to actually balance the pole or whatever object you have. That delay actually causes instability. So in the AIoT environment where we are trying to respond to real-time events coming in over the network and then automatically actually exert some sort of control using our predictive algorithms, that delay that we will encounter, or what we call the latency, right? The latency is basically the time required to transmit a message from one location to another within the distributed system. So from the IoT sensor all the way through the processing backend and then back to the actuator that will actually control the system. If the delay is very large, we will encounter what we see in this graph here, right? So for short delays, if we are going to be able to keep the latency low, we will have a stable control system. But if we have very large delays coming in and we need to actually control it, we find that we will actually become unstable. So actually, this is actually one of the really difficult problems to solve for a communication network. Bandwidth, we can easily throw in more energy, more power to solve it, but latency is something which is quite easy to quite difficult to achieve without a big change in the underlying technology. So we talk a little bit more about this in the context of some of the networking protocols that we see later on. So yeah, so volume velocity, creating huge amounts of data definitely requires us to have a distributed framework to actually distributed processing to take care of handling data. But being able to spread out the load also helps us to control the latency, because you can actually bring the processing closer to the point at which the data is actually being generated and needs to be processed, and then actually the control being sent back to the point of response. So if you can reduce the time of flight or the latency, that will actually improve the stability of the control that you have in such systems. Okay, let's talk a little bit more about the various forms and formats that the data actually comes in when you actually have this data being gathered by your AIoT sensors. So there are some very common ones. Some probably you are already familiar with because you encounter them in other contexts as well. Right, so if you take a look at the AIoT stack versus the normal web stack that we have, we will notice that actually the underlying radio protocols could be very similar, but you do have new ones being available for the IoT stack because of power requirements. And things like IP, the internet protocol, they are also found in IoT device as well, right? 6LoWPAN is actually like a convergence layer to convert your IP packets into something that can write over smaller cells that run within the simpler radio. Right, then for the transport layer, we will find that we have a UDP, the common one, and then we have a so-called encryption layer or security layer over the UDP transport called the DTLS. We may not actually find a full TCP implementation in a resource-constrained IoT device because for TCP, it does actually require things like embedded Linux or more resources to actually support it. So this is actually, so the lower part tends to be, the middle part, the internet layer tends to be more similar. Even at the transport layer, you still have things like UDP, but when you go above this, you find that there starts to see some divergence between the two. So for the application layer, we'll talk a little bit more about this mouthful of Acronyms here: CoAP, MQTT, XMPP, AMQP. These are definitely very different from the HTTP and TLS and DNS that we normally see within the web stack. HTTP is also used for IoT, for the Web of Things standard or Web of Things framework. We'll talk a little bit more about that later on. You can see that in terms of data transmission, common formats on the web like the HTML and JSON formats, they are not so common in the IoT space, except for maybe JSON, which is JavaScript object notation. This is also seen here. But we try to conserve space or be more efficient in terms of the storage that we actually require or transmission capacity that we require. So we tend to transmit not in the text format, but in the binary format. Okay, so the first common format really is just simple text formatted information. So you may have a stream of sensor readings being sent in together as a text, right? You say temperature is 36, then followed by space, then followed by maybe another temperature reading 37, etc. So this is a very simple format, and data just gets sent in this format. And Python also supports this natively. You don't need to have any special libraries to just create and read text files. Now, the data may be sent as text, but just be a bit careful that in the IoT environment, actually, a lot of the data is being generated by an embedded Linux system. So the convention for text in Linux is actually quite different from Windows. So if you're using Windows-based processing capability to run your IoT application, just watch out that the line feed character that we find in Linux actually is different from Windows, which has both a line feed as well as the character return, or the CRLF rather than just LF. So there's actually one extra character, which is the \R in Windows. So when you're reading information that's coming on from Linux, you will find that it doesn't display properly on Windows. Just need to do some format conversion for this. So the other very common format is the comma separated value format. So it's very much like the text format, except that the values are not separated by a white character, and we have a comma to be in between each values. But there may be, the first row may actually be just the header information, like what are the different columns of information that we have. As before, since this is also a text format, if you actually create this CSV file in a Linux system, it will not have the character return at the end of the line, unlike a Windows system. So this is actually currently read in Notepad, which is the Windows system. So that will be a carriage return followed by a line feed. Another very common object format that we find, as you can see from the IoT stack just now, is that JSON, or JavaScript object notation. So this is actually not a programming language, but basically using the JavaScript syntax to send in objects and data that's formatted in a particular manner. So it's basically a tag or a name followed by a colon followed by the actual value itself. Okay, so it's the encoded format where you have the tag or a name for what comes after. So it's a name followed by the actual value. So here's an example to show you what I mean. So we actually create objects, and they can be nested. So the object is actually shown by a bracket, a curly brace, right? So it can be nested. So at the end of the whole object, there will be a closing curly. So you can see that this nested object here, which has something to do with position, there's the opening curly brace and the closing curly brace. Now, if you have a series of these objects, which means that you have an array, the notation is to use a square bracket to indicate the start and the end of this series of objects. Now, each of the values themselves are separated by having a comma in between them, right? So you will have the longitude, and then which is the name, followed by colon, followed by the actual value itself. Then same thing for the latitude, which is the name of the value, followed by a colon, followed by the actual value itself. Okay, so this is just one of the popular notations that will be used in many JavaScript, sorry, not JavaScript based, but IoT devices that are sending data. Actually, the IoT device may be running C or some other programming language. It doesn't necessarily need to be running JavaScript. This is just using the JavaScript as a transport mechanism, right, to format the data. So it's not actually running JavaScript as a programming language in the IoT device itself. Not necessarily must be running it. You can be running other programming languages. So here's another example, which is actually slightly clearer than the one before. So we have an object here that has a student information. So the tag is normally delineated by, it's normally a string. So all strings have a double quote around it or single quote. So in JavaScript, both single quotes and double quotes are accepted as string delimiters. But it's better that you stick to one that you are more comfortable with. So for some people, they would like to use double quote, because double quote is actually really indicate a string for a normal human, not single quote. And the value itself. So you can see that here, normally for numeric values, you don't need the double quote. Double quote is reserved for strings only. So you can have a very, very long string. But numbers, you just need without the double quote, just the value itself. And if there's a comma, then the next tag followed by colon, followed by the value, then comma, followed by the next tag, followed by colon, followed by the value. You can have values that are actually not simple values like this, but are actually objects. So you start a nested curly brace, and then again, you have tag followed by colon, followed by values. And you can also have a list on an array of values as well, such as the cities object, cities tag here is actually followed by a square bracket, followed by you having 3 values, each separated by a comma. So that's good for normal data, but there is a problem, and that is actually what is not seen to your eye, although you can see that it's very nicely formatted here, is that there are what we call white space or separator characters that are invisible to you as a human, but they do take up storage space and transmission time when you actually try to send this thing across. So in fact, if you actually reduce the total number, all the white spaces, this thing will only consume 82 bytes. It means you take off the carriage return line feed at the end here, maybe the tab character in front of each of this, and then also the carriage line feed at the end of each of these ones as well. So there are actually a lot of hidden white space characters all over this text-based formats. So it's very inefficient. And to encode USER, NAME, each one using one individual byte itself may be also very inefficient if you think about it, because some of the names may be very long, like favorite number here. Do you really need to have so many characters for a name? Right? Of course, it's helpful for the human to read it, but it's not very helpful for the machine to actually interpret this, because it will then actually have to check every single character in this to see what actually is the whole name. So we're going to take a look at some more efficient ways of transmitting it using a binary format. So one of them that's standardized is this one in the called the concise binary object notation. It is very much like JSON. There's a tag followed by a value, but you don't need all the white space characters to separate the values. So it's actually transmitted in binary format. So you can actually look at the reference for more details about the cbor.io. So think of it as JSON with all the white space characters removed, and also that the data itself is no longer in the string format, right? It is not character by character. It's just having a single number to represent maybe the name. So you can also find the standards in all being published online at the tools.ietf.org. So that's the reference for you to just download this CBOR representation. There's also Python libraries that will actually generate and read the content for you. So you do not need to write your own Python library to do this. It's not built into Python itself to read this format. So you need to use a third-party library. And with that, we actually come to the end of the first portions. So in the next portion, we'll talk a little bit more about the data protocol. So you can see that in the data format portion, there's a common theme. We want the data to be able to represent different values, and we want to have a clear way of actually separating the different values so that we don't get confused, right? It's not just one single value, but it's actually a sequence of values. So you have to have a format that's easily understood by the programmer who needs to read in the values at the receiving end. But you also need to bear in mind that the generating end, the IoT device, is normally very limited in terms of its processing capability. So you do not want to have too complicated format. So that's one thing. The other thing is that values, as they're being sent, the fields, right, that are being sent, they need to be identified what they are. So there's need for some sort of naming or tagging capability. For the CSV and text format, they are just by position, right? You actually do not know which value is referring to what, other than the position that you find that value in, starting from the beginning, or maybe of every single line after the carriage, after the line feed character. What's the first character you see? So maybe that one belongs to the first particular field. So it's actually by position, which is quite dangerous if there's some during the transmission process, your data got a bit corrupted, then you might actually read in the wrong value in the wrong position. Okay, so things like JSON with a tag and so-called delimiters like the curly brace, right? They actually help you to detect errors like that. So it's not just by position, but there's an explicit tag to indicate what that value actually refers to. And the second common theme that we find in all these data formats is there's a need to actually send in not just simple values like one single value, but a collection of values as well, or what we call objects, where it's not just one simple value, but there is a sequence of different related values being sent together as a group, a collection, which we can see in the object notation or as the list, okay, which is just another object, but it's a more simple object because every single thing in there is the same type, right? So it's just like the cities list just now. So with this, the last thing that we observe that at least in the IoT environment, there's a need to actually conserve space so that you actually do not use up as much storage space. And secondly, during the transmission time, if you're able to make your data more compact, it will actually reduce the transmission time and hence cut latency, right? Because we have mentioned just now that latency is a problem in terms of stability. So if you can reduce the transmission time, you can also cut the latency and reduce a lot of processing overhead unnecessarily. Remember, this is Internet of Things, not Internet of People. So you don't need to maintain a readable format for the human. The human can always use some sort of advanced editor to just decode the data and then present it in a human readable form. But between the machines, they do not need a human readable form. So the binary format makes perfect sense. So this is the end of the first part. I'll come back again and talk a little bit more about the second part, where we will be talking about how the Internet of Things is actually transmitted on various protocols that we have. And you are encouraged to actually go back. Let me just go back a bit. Take a little bit deeper dive into the various tools, the various standards that are there. In the interest of time, I really did not have the time to actually delve very deeply into each of this in turn. And there will be exercises that you can find on using Python libraries to read the data and display the data as well. So you are encouraged to actually take the time to do this in between this video and the next one, to just take a deeper dive into each of these formats. The CBOR format is quite common. So let me just go back a few slides to the very beginning. So you can see that CBOR is a common format that's actually used for resource constraint protocols like CoAP. You will also see CBOR being used for other protocols like like MQTT as well. Okay, although they can also support JSON format. So you can see that there are actually so-called other industry standard or more proprietary formats for the binary space. So different companies, they actually define it. So I'll talk a little bit more about this. So the first one is actually this format from MongoDB called the Bison format. It's actually just very much like a CBOR. It's actually a version of the JSON that's converted into binary form. So instead of having words or strings to represent the tag, we have a word number to represent what it is. It's a proprietary format. It's originally designed by MongoDB, which is a NoSQL database back in 2009. Then we also have other formats such as the format from Apache, Google, and Facebook. Okay, these are binary formats, so we'll talk a little bit more about them. So the first one I'm going to talk about is the Avro format by the Apache group. So you can see that the format here, there's a reference here where you can find it as well as from the Apache site itself. So the format is that we are trying to encode things with a tag, and you can notice that the tag is a combination of both the length, right? How many values are being used, as well as the type and the name. So we don't use strings to indicate the tag, but there is definitely a tag to indicate it's like an identifier, what value it is. And then because we do not use, it's not a string, so we don't need a code characters, right, to indicate the beginning and the end of the value itself. Instead, what we actually count is the length. So it's actually, unlike the JSON format, this is actually a tag length value, right? Because we do not use delimiter characters. So binary formats, this is actually one way we can actually cut down the amount of information, and it actually speeds up the processing, because if you know imagine for the receiving end, if you know how much data is there coming ahead of time, you can just simply stop reading when the counter that you have runs out, right? Let's say you are expecting 6, in this case 12 bytes. So you just stop reading when 12 bytes are received. Or in this case, 2 bytes, we will stop reading when 2 bytes are received. You don't need to actually keep looking out for the closing end delimiter. So it does speed up processing. Because you also save 2 characters, right? So you can just encode one single number to represent how many bytes you have, rather than have 2, one to indicate the beginning and one to indicate the end of your data. So you save the space. Both the delimiters can be combined to just one single length value. So tag length value encoding is being used. So as I mentioned before, they don't use a name in the form of a string, but they just use a number to represent that particular ID for that value, what it is. So it's not by position. Just like JSON, they actually have a tag to indicate what value it is, so that you don't have to guess from the position. So another one you can see these 3 formats are actually pretty similar. It's just that they are by different companies, and they have a slight difference in the way they encode the values. So this is actually by protocol buffers by Google. It's quite commonly used in many of the Google web services as a way of encoding the information. So Google does provide a wide range of services, and this is the common format for their web services, not just IoT devices. So you can actually encode you can see that here, the first value is type number 1, and I also can encode what sort of value is it. Is this a string, or it is a number within the tag? Okay, and I do not use string as an indicator. I use a binary encoding to indicate what type of data it is. So in this case, it's actually a string, and I know that it is length 6, so I am expecting this. And it. And they can also separate the other types, like string is again the same tag. Right. So it packs the field type and the tag number, this one within a single byte. So rather than encoding it in many other separate bytes. So it's pretty efficient. Now the next one that we'll talk about, which is again very similar to protocol buffers, but it has two forms. The first form is different from the protocol buffers. So in this case, the type and the field type of value, right? Whether it's a string, etc., is actually in a separate field. So there's a type data type number as well as the tag number. So the first byte indicates what type it is. It's a string. Then the next one is the name, right? The ID for the field. Then how long it is, and then followed by the actual value itself. It is still tag length value encoding, but the tag is having a separate one for the type tag length encoding rather. So just like the protocol bump, actually there's a compact form of this thrift protocol. So the type can be combined together with the field information. So you end up something like the protocol bump, where the field, the type and the tag are actually combined together. So this is the non-compact form, which is having both the type and the tag separate. So we have the type first, followed by the tag, followed by the length, and then the value itself. And again, you do not need comma, you do not need any separators. So that really saves some space, because between every value you would have to have a separator for JSON. But here, because it's length encoded, I know where it ends. So the next value is just the next type value, etc. Right, so that comes to the end of this part about data format. So after this, in the next series of videos, we'll talk a little bit more about the actual data protocols that are used themselves for transmission purpose. So thank you for your attention. I'll see you in the next series of videos.